Hi. Hi everyone. So my name is Louise Capener and I'm going to be leading today's computational social science introductory workshop. We probably do have a few people still filtering on through, but we have a few slides anyway to introduce things. So hopefully everyone will be here by the time we start. So yeah, just a little disclaimer before we begin. This session is focused on introducing you to the concepts of CSS, so computational social science. So we're not going to be covering more advanced topics, including, the epistemological and theoretical challenges posed by CSS, nor are we going to be focusing on the ins and outs of one particular computational methodology. Although if that is of interest to you, you want to look at a particular technique or computational methodology, we do have a ton of resources on different computational methods. And Emma, again, sorry to actually post another link in our chat, but if you could post a link to our YouTube computational social science playlist and also our GitHub. So our GitHub has a lot of repositories which contain interactive coding notebooks and other materials which might be of interest to you. And we have a bunch on, for instance, text mining and some more machine learning, all of that good stuff. Okay, so in this talk, we're going to be covering three main sections, which include, so the first one, we're going to be covering what is up with computational social science. So what does this even mean? Then secondly, we'll look at, how do I become a computational social scientist? And then we will go on to the 8 steps of computational social science, which is where we'll have the most interactive part of the workshop and where you can get stuck in sketching out a potential CSS project for yourself. And of course, at the end, there'll be time for final thoughts and any questions that you might have. So what is computational social science? So it is the use of computational and empirical methods to address social science questions. So let's break this down a bit more then. Computational social science requires human thinking to identify important research questions. And because we're dealing with social science questions, we need to understand how people behave and what they want and what it is that they want to achieve. So we're going to need that social science brain in order to formulate those really interesting research questions. But we're also going to need a sprinkle of computer thinking in order to turn these questions into computational or empirical methods. And after completing your research, you're going to need that social science sort of human thinking again to effectively communicate those results to other people. So another way to understand computational social science is to think about what its main components are. And we can sort of get to that as well through thinking about, what it's not. So let's just go through a few points. So computational social science is not just using computers within a social science research project. It's not just using digital versions of purely traditional social science methods. So, it's not just using SPSS, for instance, a popular statistical software to analyze survey data. And it's not just using digital but purely non-empirical methods. So I'll go ahead and untangle these a little bit because I know that they're not always entirely obvious. So what we have now is a few examples that might help put this into context a little bit. So one example of a computational social science project would be collecting, processing, and analyzing millions of online news articles to show changing political attitudes. So you can see how we have that social science sort of human thinking here to formulate our research question about political attitudes, but also that computer thinking that's inherent in using a computational method. So in this case, we'd use a method called web scraping to sort of trawl through the internet to gather a massive amount of news articles. Another example could be using real-time weather and traffic data to look at how travelers react. So for example, maybe you hear that there's a new storm that has caused damage to a local town, and you want to look at how people react and how this event is dealt with in real time. So you can see how this project isn't just a case of using a computer within a social science project or using a digital version of traditional social science methods. Instead, we have these uniquely computational methods. And we have some other examples too, which include combining data from novel wearables or apps, maybe to establish a correlation between social media activity and heart rate. So, for instance, you could be aiming to answer a social science question about how people feel about certain images. So you could look at how they react. Are there positive or negative feelings, or are they irritated, and so on. Right, so where was it? Yeah, and finally, we could be interested, for instance, in mapping family names over time by importing, processing, and formatting centuries of parish records. So this could allow you to maybe explore the movement of certain families to different areas. Maybe you could explore the changes in family sizes or whether they moved away or not. So these are just a few kind of broad but really key CSS examples. And when I say CSS, that's just computational social science. I'm going to use that quite a bit because it's a bit of a mouthful saying computational social science each time. So moving on, there are key factors that are going to make a CSS project computational, with the first being data volume, complexity, speed, difficulty, or novelty. So this is going to be more important than the exact data source or type. So for instance, in our previous example of parish records, the source of the data is not entirely important. It's about, the sheer volume and complexity and difficulty or novelty of that data. But additionally, as we said, because we have that social science element, the data must pertain to people, actions, behaviors, choices, statements, etc. So yeah, we should have that social science research question in there, which is going to use this atypical data to talk about how people make decisions or what influences their behavior and choices. So the exact research question is not really important. It's just that it has to be a social science question. And this is kind of where we have that really obvious intersection then between the computational methods and the social science. And that's what we're going to be focusing on and looking at today. So we have a really nice little quote here, which says, in essence, computational social science is an opportunity to do socially valuable research that would not be possible without computational methods and tools. So by this, I mean that, we couldn't, for example, manually scan years and years of police recorded statistics to try and understand how crime rates have changed over the last 10 years. This physically wouldn't be possible to do manually, or at least it would take a long time. But with the use of computers, we can apply advanced statistics and models to sort of understand this change, this kind of change in crime rates. So we can look at how we can count many types of crimes that have taken place in certain areas and aggregate these crimes to map them spatially. We could explore the long-term trend seasonality or noise components of these different crime types. And this type of research just wouldn't be possible without the use of computational methods. And if that is something that does really interest you, sort of mapping crime data, that kind of thing, I really do recommend you to check out my colleague Nadia Kenar. She's got a workshop which is on the YouTube. I think it's on the CSS playlist that Emma dropped in before, and it looks at using R, the programming language R, to sort of like map crime in certain areas. It's super interesting. You can make really cool visualizations, and it's very easy for beginners. So do check that out if maybe you finish this talk today and you're really inspired. You think, okay, I want to get hands-on with my first CSS little project. You can go ahead and follow that talk. It's really good. Another example of project you could do, which I mentioned before, is web scraping millions of online articles to try and understand how, let's say, how political opinions have changed over 20 years. So in order to get a sense of those political opinions, we want to examine, the words in articles and maybe how many words belong to different categories and what sort of themes appear and what the proportions are of these words and how that maybe changes over time. So again, this is something that we wouldn't be able to do without that computational method, which is web scraping. So we use different tools, and we can use APIs to access, for instance, social media data, and we can scrape a lot of that data. And to see whether any of that kind of made sense, whether I've got the concepts down right with everyone, we're going to have a little bit of interaction and give you guys the chance to vote on whether you think a given project is a computational social science project or not. So if you would like to head back over to Mentimeter, we can get this set up and then you can start voting. Okay, so I will give you a little bit of time, so don't worry if you're not there yet. You just check the chat, see if everything's good. Yeah, so Emma's just popped the code in for you again if you need it. So our first example involves a project where we want to scan historic recipes and use AI algorithms to recognize text with the aim of identifying ingredients and measures used over time. So yeah, what do we think? Is this a computational social science project or not? So we've got someone straight out the gate saying, nope, there's not enough social science in there. Well, let's see if some of the results come in. Some people saying it's definitely CSS. So yeah, it's interesting that no one's put that there's not enough computation, which you know, we definitely do have computational methods being used here, right? Because we've got this AI algorithms. But yeah, I suppose an issue could be that it doesn't seem to be a social science project. It's not really, you know, can't really tell from this question, but we're not really seeming to be asking any questions about people's behavior and choices. Yeah, so I agree with people that say that saying it's not enough social science because, you know, what are we talking about here? Are we talking about how imported foreign foods integrate into domestic scenes and how people take that up, or maybe how it relates to wealthier people sort of eating fancier foreign things? It could be exploring how that trickles down and then these foods become normalized and accepted. You can see that there could be a social science question in there, but if we just take it at face value and we're talking about maybe proportions of different foods in these recipes, then you know, it doesn't seem to be very social sciencey. So just, yeah, so someone's put in the chat, my interpretation is it's too quant. Yeah, I can understand what you're saying there, yeah, and it wouldn't matter as much, I guess, even if it was a bit quanty, if we did have this social science question, but it doesn't really appear to be obvious here, does it? This is one of those exercises as well that I know can be a bit annoying because there's not always like one definite answer. This is just really to get us kind of thinking about these ideas. So yes, for those that have said they need more information, you're also bang on because you know we don't actually know enough about the question, right? Like maybe there's a social science question in there. But yeah. So let's head on to the next example. Okay, so is this computational social science? Is this a CSS project or not? So this time we're using gamified smart home displays in order to understand how people interact with energy saving technologies. So right now we're 50-50 with some saying it's definitely CSS and then half saying there's not, but it's just switched now. And we've got 75% saying it's definitely computational social science. Some saying that there's not enough computation, which is quite interesting. Well, let me just wait a bit because sometimes it's hard to talk about things as they sort of the results are coming through. I'll let it settle a minute. Okay. So personally, I would say that this one is probably computational social science. But again, as with the other question, it does depend. It is really hard to capture the nuances of a research project in just one sentence. So it is hard to know what the purpose is and what, you know, you're expecting the conclusions to show. But I would think that a gamified smart home display would probably capture a lot of digital data about how quickly people react in terms of, you know, maybe looking at what time of day it is or who it is that's interacting with it. So I think, in my opinion, we've got the computational element down. We could think about maybe this gamified home display is acting as some sort of tracking data, or maybe the purpose is to try and change people's behavior, because it's, you know, it's about how people interact with sort of energy saving technologies. That would, in my opinion, definitely pose some sort of social science research question. So yeah, this is where we circle back to how we conceptualize our thoughts and processes. But yeah, it's interesting to see that there's quite a bit of a division on this one. And again, there's some saying we need more information to decide, which fair enough. These are just like one sentences that we're trying to extract something from. So definitely agree with this. But yeah, I would say, in my opinion, it's definitely a CSS project. We have the computational element, gamified smart home displays, which we're gonna get some data from, and we're looking at how people interact with that. So I think there's like a behavioral component there for sure. So let's head on to our next one. So here we have a project which is involving advertising for survey participation on social media, and we're going to store the responses in a database. So what do we think? Just wait for things to roll through. Sorry, I'm just going to let my cat in as she's crying at the door, and it's going to be very distracting otherwise. 2 seconds. Okay, so we've got an even split here. So half of you are saying there's not enough computation. And yeah, I'd agree with that. So if you remember on a previous slide, we talked about how, CSS projects, they're not just using digitized versions of traditional survey methods. So, if you whack a Survey Monkey link on Facebook or whatever, that you're not doing computational social science, because you could just collect those responses, manually, like getting people to fill them out. So it's not just using those digitized versions of traditional survey methods. There is no kind of clear line between how much computation is enough computation, but you have to ask yourself, if you could easily do your research without digital tools, then it's probably not computational social science. And if we draw the conversation sort of back to surveys in itself, typically the larger the survey sample, the more necessity there will be for computational tools, because the analysis is going to become much harder. But again, still that use of online surveys doesn't automatically make it a CSS project, as you could probably collect roughly the same amount of responses through paper surveys as you would online. And then we also have half of you saying that, there's not enough social science, which is also valid, as we have no real research topic that this is focusing on. We don't know what it's about. It could be just collecting responses about participants' weight and height, for instance. So yeah, absolutely bang on. Let's move on to our second to last project here. So if you're feeling a bit questioned out, don't worry, we're going to be done soon. So this example looks at reading in real-time weather and air pollution data to create complex models of hyperlocal air quality. Okay, so currently it looks like the majority are saying that this is not a computational social science project due to a lack of a social science focus. Votes are still coming in, but I'll just talk about them as they do. So yeah, we have to think about it. Is there a link between hyperlocal air quality and human behavior? It's tough. I'm not sure if there is. At least there's not enough information in this question. We'd have to know more. Are we looking for a political impact, or is there going to be an overlap between different research fields and schools? So maybe with something more geography-based, geoscience, something like that, or with physics. It's just not clear by this statement that there's an intent to explore human behavior. So I would say I'd agree that there's probably not enough social science in this statement. But it is interesting to see for this one, there's not as much division compared to the sort of first example that we did look at. Some of you are saying that there's not enough computation, but I think if we're looking at real-time weather and air pollution data, we've definitely got our computational element down. And there's some of you that said definitely CSS, and again, it is one of those frustrating sort of exercises, because the questions are quite short. They're intended to make you think about ways in which it could be. And, if we look at how this relates to human behavior and we think about a link there, then, it definitely could be. Okay, so let's move on to our final question. So what we're looking at here is we're going to look to train a neural network on social media data. And our aim is to create a believable chatbot that counteracts online radicalization. So what do you think? Is this a computational social science project or not? Okay, so looks like the majority of you are saying that this is definitely a computational social science project. And again, I think I've had to agree. It seems to include all the components of a CSS project, and we can just walk through them a little bit. So there seems to be an implicit social science research question as we're focusing on people's actions and attitudes and behaviors. So we're going to be aiming to counteract online radicalization. So we're aiming to change behavior. And to do that as well, we're going to use a computational method to help us explore this. So we've got a neural network which has been trained on social media data. So for those that are unfamiliar with that term, neural networks are a kind of artificial intelligence that teaches computers to process data in a way that is inspired by the human brain. So, it's a type of machine learning process also called deep learning, and it uses sort of interconnected nodes. So you can think of them as like the neurons in a brain in a sort of layered structure that is going to resemble the brain. So this is being implemented in the hopes that we can use it to predict the user's behavior based on their social media posts and messages. So in order to train this model, there's probably been a fair bit of web scraping involved. So definitely have nailed the computational component. And in order to sort of counter online radicalization, we of course are going to need to have good ideas about what online radicalization is and how people are radicalized and what sort of mental processes are going on. So I definitely think we have a social science element covered quite well here. We need to understand how people interact with each other. We're looking at how we convince people to accept an idea or a question. So there's methods that need to be put in place to understand how people change. And if we're looking at sort of analyzing text as well, we could do this using something called natural language processing. We do have a few workshops on this as well. So we have a lot of stuff on sort of text mining and using natural language processing techniques such as sentiment analysis on our YouTube playlist as well. So again, if that's of interest to you, they're all very introductory and you can check them out. So yeah, if we wanted to, we could use this natural language processing to get more of an idea about the breakdown of language. So that could be one way we could do this. So what we're doing then certainly seems like we've got a lot of complex computational methods that are going to mimic and interact with individuals. So this would be, in my opinion, a quintessential CSS project. So that was our last example. Thanks for taking part. I think it is quite useful to explore the sort of components that make up a computational social science project. Let me just check the chat. Someone said, I'm going to use AI to investigate, detect, prevent witchcraft and harmful practices in Southern Africa, CSS or not. That's a good question, Keith. I would say it sounds to me like a computational social science project. So we've got that computational element, which is using AI, and we are aiming to sort of prevent a behavior and a harmful practice. So I think we'd have a lot of social science research to back that up. So, talking about what witchcraft is, how are we going to use this AI to persuade, against it or to prevent it? That sounds like CSS to me. I'd be interested to know more about it. And when we get to our 8 steps, we're going to like sort of walk through what like a little sort of test project. So definitely keep that idea in mind. So yeah, the last thing to do before we leave this is just a little word cloud. So go ahead and feel free to enter up to 3 words that you've learned about computational social science so far from these slides, or maybe something that surprised you, or something that you found interesting, or maybe something you're still curious about, or maybe you feel that I haven't covered enough, just pop it in. No pressure though, some of you might have moved off from Mentimeter, so we can just linger on this for a minute and then hop on to the next slide. So maybe I'll give it a minute, but don't worry if you have sort of gone off Mentimeter, it's not a problem. All right, nice. So data, yep, for sure. Social science, the concept itself, yeah, we're mainly focusing on that today. I know that there's sometimes people come along to this sort of talk and they maybe expect us to get a bit more in depth into sort of like particular methods, but this really is just like intended to be like a gentle sort of overview. So we will be covering the more conceptual sort of stuff. What could be CSS? Yep, for sure. Data amount, yep. So we talked about like the volume, so that sheer volume of data and why, computational tools could be good for it. We talked about, the example of like the police having to scan, years and years of sort of police data in and how to use computational tool for that. So yeah, social media, yep. Such an amazing avenue for research. Some really cool things come out from social media research with people sort of scraping tweets and stuff like that. Still social science, yep. So that's what makes it CSS is that we're prioritizing this social science focus. Really, really important. High power computer, yep. Especially if you're dealing with a lot of data. Practical, yeah, tools, very, very important. I'll sort of move on now, but thanks for sort of engaging with that and heading back to Mentimeter. I probably should have said there was a final bit of interaction. Okay, so we're going to talk a bit about how to become a computational social scientist. So we will start by covering what a social scientist is. I know this might seem a bit basic. Some of you might be thinking, well, I already am one, but it is good to sort of go through the sort of skills that you might already have as well, because it can just be a bit reassuring. I know as someone who's sort of gone from doing just social science to computational social science that I was really intimidated by the sort of computational element, that this is kind of reassuring because it shows that you do actually have a really cool and good foundation to build on. Okay, so social scientists think like people, okay? And what I mean by this is that as social scientists, we use a lot of those very human type thinking skills like abstraction, inference, and we're pretty familiar and at ease with fuzzy concepts and background knowledge. We don't really shy away from grey areas or overlapping categories, as these are just part and parcel of being a social scientist. And it's no surprise that we need these skills because we're studying people, interactions, and behaviors, and that is quite complex and it's going to require a certain skill set. But social scientists also do build up a ton of data skills in the course of their research. So if you think about things like response categorization and coding, quality evaluation, pattern detection, and statistics, these are all going to be things that some of you might be familiar with. And I will say, if you can get your head around some statistical software like SPSS and Stata and all that kind of stuff, then you're actually gonna have like quite a good foundation because you're used to sort of getting to grips with these complex tools. But whilst you do use computers, this often might not involve writing computer code. Instead, it may involve, like I've mentioned, those computer programs such as SPSS or Stata, but there will be that sort of lack of familiarity maybe with code. Although some of you might be writing syntax on SPSS, I know that is apparently a thing. But yeah, not sort of like traditional, I guess, coding. Whereas we then have sort of computer scientists. So again, we're making really big generalizations here. But in contrast to the sort of human type thinking skills that social scientists have, so that sort of familiarity with like those fuzzy concepts and abstraction, all that good stuff. We could say that computer scientists are taught more to think along the lines of computers. So the thinking skills that they're going to have to sort of hone are more along the lines of concrete definitions and absolutes. They're going to be thinking more in terms of strict hierarchies and categories and clearly defined and scoped variables and rules, because that's just, the way that coding works. There's very strict rules. You're learning a language, and then there's ways to implement that language. And in terms of data skills, computer scientists are going to be quite used to collecting and analyzing and manipulating data through programming scripts and computational methods and technological tools. But unlike social scientists, they might not be taught as much to identify or motivate research projects on the basis of societal impact or value. I'm definitely not saying that, this is never the case, of course not. But for those of you that are social scientists, you might be much more familiar with justifying your research on the grounds that it's going to make the world a better place. It could be I'm researching radicalization in online forums in order to produce insights that could lead to countermeasures, or it could be, the example that Keith put in the chat about sort of like using AI to have a look at sort of witchcraft practices in order to like sort of persuade people against them, or to come up with policies to sort of like stop these like harmful activities. Whereas a computer scientist might be more focused on a sort of logical justification for a particular project. So it might be, I've got this algorithm and I'm aiming to make it more efficient so that it uses less memory. Okay, so you can see with that, it's more technical, and there's a lack of this social science element. So in order to do computational social science, you're going to need a blend of social science and computer science skills. So you're going to need that, human type thinking skills, the ones I talked about with the social sciences. You're going to need a little sprinkle of computer thinking. So sort of learning how to think a little bit along the lines of the computer. And you're going to need open-mindedness for sure, and you're going to need a mixed problem to work on. So let's sort of go over these one by one. So yep, you're going to need those skills that we touched on before. So you're going to need to be able to identify important problems or knowledge gaps. You're going to want to consider possible solutions. You're going to need to connect problems to relevant theories or perspectives. And you need to be able to collect relevant information and research to frame your approach. And these are all the things that social scientists we excel at. So that's the ability to understand context, nuanced perspectives, how to communicate abstract ideas, and how to attack a research question. Whereas this might be an area where computer scientists may struggle, as they're more used to working along those concrete definitions and absolutes, rather than the sort of grey areas or murky social science concepts. So that's going to be the first thing that you need. So for computer thinking skills, what are we going to need then? So we'll need skills like the ability to access, organize, process, and handle vast or complex data. So, like I said, for instance, a project that's going to sort of collect like millions of online articles, right? We're going to need the ability to scrape those articles, to organize them, to put them in a table where they're all sort of like correctly labeled. We're going to need a way to handle that data. We're going to need to know how to write collaborative code. So, it's a lot of times when you're working on a CSS project, you might be working with other people. So you're going to need to know how to sort of like write code and work on things together, and how to properly document your workflow, which is often a step that people do neglect. So these are all skills that computer scientists are going to be more sort of familiar with, as well as data scientists who have been trained in computational methods. But for social scientists, it can be much harder to sort of transition towards those computer thinking skills. But like I've said before, we've covered this because it's reassuring to know that social scientists do have those data skills they can build on. So, we are sort of familiar with coding responses, pattern detection and statistics, formatting surveys, that kind of thing. And this is really important. You might think such a wishy-washy slide, but I can tell you as someone that has sort of gone from a more social science field to doing more CSS type stuff, it can be really intimidating at first, or at least that's exactly how I found it. which is why it's good to remember that, no one starts out with all the skills that they need, nor are you going to know all the skills that you might need to acquire. And this does happen quite often. So you might start off saying, okay, well, I want to scrape some tweets for information on the 2016 US election. And you're going to expect, okay, well, I'll need some coding ability, right? But you might not know that this entails learning about what an API is, or what different file formats, how are you going to import the data, or how are we going to visualize this data? But if you do approach CSS with an open mind and a willingness to learn, you can gain those skills. And you'll start to understand as well that some skills are going to have a much steeper learning curve than others. So, it might be fairly simple to learn how to do a little bit of web scraping, but learning, for instance, how to build your own neural network and train it on a large amount of data, that might be a bit more complex. And this will lead you then to collaboration with those from other fields. So yeah, it's important to remember that you can't do it all by yourself. It's good to sort of be aware that you can actually collaborate on these things. You don't need to be the expert, but you could maybe if you're working at a university, or I don't know, you might be a student, you could go to other professors that have expertise in this and sort of collaborate on a project together. And finally, you're going to need a problem that requires these CSS skills, and that is a mixed problem. So one that's going to require that blend of social science sort of thinking and computer science thinking. So let's talk about this a little bit more. So some of you might be here because you've already encountered one of these problems. I wouldn't be surprised, because as resources become more digitized, these problems are going to become more relevant. We've got the fact that, everything seems to be becoming more smart and networked. We've got the fact that, the internet generates such a vast amount of data that's made available and it's updated faster than ever. So if you think about a classic social science problem as well, aside from sort of the web, maybe we're interested in how men and women move through cities differently, or we want to narrow that question down, and maybe let's say we want to look at how people with disabilities navigate through cities. So traditionally, for that kind of social science problem, you might station some interviewers in different places in the city to stop people as they go past. You might maybe count how many people go by that are using mobility aids, or maybe you'd send out surveys to people's sort of houses. But now there's much more opportunity for us to gather a large amount of data with computational methods. So you could collect data from public transport networks about how many people bought tickets, or how many people are swiping their card at the tram stop. Excuse me. You could even get sensors which track how many cars go past a given point. Or, you could use AI algorithms and CCTV cameras to identify how many people are actually moving through a space and at what speed. So as you can see, there are all these like fantastic new ways of approaching traditional social science questions. But, I will also stress there's no reason as well to abandon traditional methods completely. This is not saying that these methods are, they're old, they're archaic, and we don't need them. Part of good research is evaluating different methods and comparing outcomes. And it might be interesting to see whether by using different methods, you get different answers. And if so, you can ask, well, why is that? Which then may prompt further questions and sort of like really hone your research. So this is quite, I appreciate it can be a difficult task, but it has a lot of benefits in terms of building upon your computational skills and strengthening those social science skills that you might already have. So before we move on to the 8-step process, I did notice that a few times I've done this workshop, a few people have said that they want to know more about sort of the career path, or, how someone finds their way to doing computational social science research. So I thought I'd highlight my colleagues in my CSS team and their background. So you can see that we have my boss, so on the far left, that's Jules. So she actually did an undergrad in linguistics and then a master's in evolution of language and cognition, and then went on to do a PhD. We also have Nadia, who did criminology at undergraduate level and then did a research master's degree in criminology and social stats. And finally, I wasn't going to put a picture because I just think, it's probably a little bit cringe when I'm right here. So I did politics at undergrad, and then I did a conversion degree master's in data science and AI, which was aimed at students from a computational science, computer science, sorry, background. And I did that at the Uni of Liverpool where I did my undergrad. And I'm not highlighting this to show, oh, look at us. I'm highlighting this to show that, there's no computational social science degree, not yet anyway. I do think there is more sort of like computational social science type degrees popping up out there. I know that the Uni of Manchester now offers a sort of master's in social research methods and statistics with computational social science. But what I want to stress is that, you don't need to have studied this at undergrad or for your master's to do a CSS project, because chances are your undergrad and your master's or your PhD have provided you with useful transferable skills that you can use to carry out a CSS project. And, you might even be joining from sort of like an NGO, or, you might not even be in education. It can still be doable, and it's still, you're still going to have skills from other areas in your life that you can sort of pull together to carry out a project. And that's what our learning materials and sort of talks are designed for. They're designed for those that haven't done a CSS project before, and we always sort of pitch things at complete beginners. So you can see that Jules has gained a lot of sort of text mining skills and a knowledge of how to perform statistical analysis in her undergrad, and also learned about advanced stats and agent-based modeling in her master's and their PhD. Meanwhile, Nadia, sort of like many of us, has gained skills in her undergrad related to traditional statistical software, so things like SPSS, and then was introduced to the programming language R, which she then used primarily in her master's. Okay, so as mentioned in the previous slides, you're not going to need to be an expert coder to carry out a CSS project. After all, collaboration is key. And for those of us who are students or academics that are working in higher education, we are really lucky to have a big sort of reservoir of potential collaborators to work with. So, consider reaching out to enlist a programmer or an expert on neural networks to help you if you've got a particular project with that in mind. But to carry out a successful CSS project, you're going to be expected to have some knowledge of programming languages, so like R or Python. And that's because these languages offer packages and libraries which help you to implement your computational method. So in our team, for instance, Nadia is our resident R expert. And some of you might have heard of R already, as it is becoming quite popular in the social sciences now, and it's been used for a while as well in other sort of fields like biomedical science, biostatistics, and that kind of stuff. If you previously used Stata before, you will find that it's quite similar. It's really user-friendly and it has quite a nice approachable layout. And you'll have the benefit of as well of not having to sort of faff about with picking a code editor or sort of IDE, as that's all provided with RStudio. And it's also great for producing data visualizations. So it's a good choice for those that have already got a background in statistics, as you'll probably find the syntax and the functions more intuitive. So if you see on sort of left-hand side of the screen, we've got it shows you what RStudio looks like. So you have this nice kind of like 4-paneled sort of software here. So if you are sort of familiar with like Stata, I would say R is a really good place to start. If you're sort of like thinking, okay, well, Python R, where do I go? Whereas me and my boss Jules, we mostly use Python, and that's just down to what we're familiar with during our masters. Although I do think Jules has used R a fair bit too. When it comes to Python, it's more of a general purpose language, unlike R. So it's not just limited to data science. It has a broad user base and is popular with web developers, software developers, etc. But it is also known for its simplicity and readability, so the syntax is pretty easy to pick up. But unlike R, you do have to do some shopping around for what sort of coding editor you want to use. So for instance, here you can see I'm using this coding editor called Jupyter Notebook that allows me to structure my codes in these nice little chunks, which is quite useful. You can also do that in R as well. It's just going to be what you like the feel of. So, do play around with these and see maybe which one you like. But yeah, I'm not going to go massively into this side of things. As I've said, I just really do want to do sort of an intro workshop, but I would say the biggest learning curve for me for getting into programming and computational methods was sort of setting up my computational environment and learning basic code. And what I mean by setting up my computational environment is stuff like how do I navigate my command line and install software or coding packages? How do I write my first function in Python or R? And that's why we're going to be hosting a coding anxiety club soon. We're going to aim to host it sort of twice a month on the first and third Tuesdays of each month. And it'll just be a half an hour session. We're probably looking at doing it maybe half 1 to 2, where viewers can sort of just come along and learn some key skills, which we'll be demonstrating live. So look out on our events page for that, because, it can be nice to sort of like just type in the YouTube chat, not have the pressure maybe of joining by Zoom and just, see if you can come along and pick up some skills. Okay, so before we might, I'm going to ask you again if you want to take a short break, but we'll see. But what I want to do is quickly introduce an 8-step process for how to undertake a CSS project. So after the break that we might have or not, sorry, I'm just reading from my notes. We're going to go into more detail about each of these steps. So these steps are going to be about identifying problems, exploring the problems, formalizing our concepts, collecting data, implementing software, and verifying the concepts. Then we'll be using those concepts to experiment or analyze data. Excuse me. Then we'll cover discussing your findings and presenting a conclusion, then communicating, publishing, and presenting, and finally sharing your findings as well as documenting and validating your findings. So to make this process useful to you, I want you to start thinking about either a project that you'd like to tackle or a research idea that you've been thinking about, or it could even be a project that you've done in the past. You could maybe jot this idea down, or we will have like a little bit of interaction via Mentimeter where you can talk about it. But yeah, maybe just keep it in mind as we go through these steps. So once you've identified the problem, you're going to want to be as clear and specific as possible about the pattern, the problem, or the lack of insight. You'll also want to identify who is involved, where it is, etc. And what this is going to do is it's going to help you define your research question. So maybe we have a goal in mind. So, I mentioned before about people traveling through city centres. Maybe we want to get people doing this more, we want less cars on the road and more people riding their bikes or scooters, or, just being able to get from A to B in their wheelchair. So the research question might just be something simple as what are the barriers to active travel in city centres? What I'd need to do then is identify who is involved, so I can just start to make a list of things, whether this is going to be potential companies, people, different demographics that may be of interest to me. And so I might make my list and I might say, okay, I want to look at city councils, bus companies, different businesses, different types of vehicles. And it is better as well when you're making these lists to just go all out, as that's going to give you different avenues to explore. And you can always cross out any after you've done a bit more investigation into them or decided that they're, not actually relevant to your research. I'll just check in the chat. Keith said he's going to jump into another meeting. Yeah, no worries. Thanks for joining. No pressure to stay to the end. Just come and get whatever you need out of it. It's all good. And then the next step will be exploring the problem. So this is where you're going to be gathering information and perspectives in multiple ways. So you might think about surveys, observations, secondary data analysis, web scraping. So this might involve conducting a few interviews with people of interest. So for instance, sticking with my example from before, maybe I could interview the manager for my city's transport network or some local council workers. But you'd probably also need maybe a survey or observations or secondary data analysis to capture how many people are actually moving through the city centre. So it's going to be about using different methods and tools to further enhance your understanding of the problem or the research topic. So you're going to want to spell out sub-problems, processes, relationships, simplifications, assumptions, related issues, etc. So after settling on your main research question, you're going to need to get more specific in order to make that question relevant and measurable. So if my sort of question is, what are the barriers to active travel in the city centre? Maybe that's my main question. I might then enhance this by focusing on, making it a bit more specific. So it could be, what are the barriers to active travel through this specific city centre at this time of day, given the way that these roads are laid out or whatever. So yeah, this is where you really nail down the particulars of your research question. So if we head back to Mentimeter again, you can feel free maybe to tell me a bit about your step 1 and 2. So no worries if you don't want to share. You can always just keep a note of it for yourself. You might just want to get some of your own research ideas flowing. And it doesn't have to be well defined. I know it can be sort of hard to outline your steps if you've only got a vague idea. But for step 1, it could be as simple as, people on Twitter from different political camps really seem to hate each other. I want to look at political polarization on Twitter. And then your step 2 might be, I'm going to gain access to Twitter's API and see what I can find by scraping some tweets and maybe see how I can build a big data set. Of course, those that are familiar with Twitter or X as it is now will know, unfortunately, that API is now not accessible. You have to pay a lot, which really, really sucks because it's such a good source of like data to explore, particularly for like political opinions. But yeah, I'll see if anyone wants to hop on Mentimeter. If not, I'll move on to the next slide. So yeah, I will just head on. Not everyone always wants to share these things. It's totally fine. Okay, so let's move on to step 3. So for step 3, we're going to need to formalize our concepts. And what I mean by this is that you'll want to make all the concepts and processes explicit, formal, and both computer and human understandable. So when it comes to making things sort of computer understandable, we often work with something called pseudocode. But you don't need to know how to write code. You just need to start understanding how to formalize things. So for example, maybe your research question focuses on trust, which is a very social sciencey sort of concept. And maybe your goal is to get a computer to be able to measure it or to model it or even represent it in a situation. So you're going to have to look at sort of how you define that concept, trust, in a way that a computer would understand. So maybe if you're doing some sort of simulation or something, you might define trust as a variable between 0 and 100. And then you'll need to sort of institute rules about how that variable will change in certain situations. So if you have 2 parties that you're simulating and they interact positively, then trust could increase. But then given a negative interaction where one of those parties is judged to be deceitful, that level of trust could then decline or reset to 0. So you have to start thinking about how to formalize concepts in your research question so that a computer will be able to interpret it. And I'm just going back to this because I saw that someone put something on it. I have access to Facebook posts, meta content library, but I'm struggling to find a social science topic. It feels like every topic can be explored superficially in the beginning. Yeah, coming up with a topic can be hard, I suppose. Yeah, Facebook's a particular sort of platform too. You could maybe think about demographics first. So I know that Meta and Facebook used to have sort of like quite a young sort of user base. I know that when I was young, it was definitely all the rage after what was it, MySpace? So like me and my friends would post on there a lot. So it could have been back in the day like quite a rich source for like data pertaining to young people, but it now seems to be more used by a slightly older demographic. So that could maybe sort of like impact on your research topic. Because you have to think about these things like when we're looking at, for instance, Twitter data. I know the user base tends to skew a bit male, tends to be much younger, so that's also going to affect your results, right? And maybe it's going to impact what sort of topics you look at as well. So yeah, it's a hard one. maybe something to do with political posts. I know that there's a lot of stuff about certain conspiracies and being shared on Facebook. I think a few years ago there was a lot of stuff about the QAnon and COVID vaccine stuff being shared on Facebook. So maybe it could be something related to that. Or, a good way as well to find sort of a topic is to look at what other people have looked at as well. So you could look at Google Scholar. You could see what other people have sort of looked at, not to copy their idea, but to sort of, bounce off it and think, oh, okay, well, that actually makes me think of a different but maybe related concept that I want to explore. So maybe you could have a think about that. But yeah, don't worry if you haven't got the sort of topic nailed down. Yeah, just for this as well. So the next step that you'll have, step 4, is going to involve collecting data, implementing software, and verifying your process. So this is where we are going to select and implement one or more methods. So many of you might have thought about these methods in step 2. So maybe you might have thought, okay, web scraping or agent-based modeling or sentiment analysis. So this is where you implement these methods and you make sure that they work in the way that you expected. So maybe, there's a lot of things that you encounter when you're doing like a sort of more computational project that you don't expect. So maybe, for instance, the data comes in a different format that you expected. My colleague recently was looking at my boss Jules was looking at the predominance of like person first language in relation to sort of like scholarly abstracts on I think autism. So she was looking at how predominant it is that in these abstracts people are using sort of person first language, so like person with autism as opposed to autistic person. So when she started doing that process, the data was in a different format than she expected to be working with, and she ended up working with like a lot of sort of PDFs, and that was like an enormously large barrier to get over because you had to parse PDFs slightly differently than you would different forms of data. So yeah, you can often come across these unexpected things, or maybe you're just getting a bunch of error messages in your code. So this step is thinking about how can we make it work in the way that we expect. I often come across this, sort of like working with a big data set and I'm getting an error in my code. What I often then do is think, okay, well, maybe I can work with a really small version of this data set to see where things are going wrong. Like, where is this code stepping through my data set wrong? So then I tend to just think, okay, let's work with 3 rows of data, you know? So this is where, you sort of fine tune your method and you iron out the kinks. And of course, as well, when it comes to the choice of method, that's going to be highly dependent on the research topic as well, right? And lastly, you need to thoroughly check that the method has been implemented correctly. So that's what we mean about sort of verifying your process or method. It's about answering the question, did we do the thing right? So if you want, you can feel free to talk about what your steps 3 or 4 would look like. Again, I know this might be hard as you've not actually undertaken the research or implemented any methods, but you can sort of share any vague ideas that you might have. So I can go back to this one here. So I don't actually know much about sort of scraping Facebook posts, but you said that there's a meta content library. So yeah, I guess you're going to be using something to sort of scrape those, or maybe there's a really easy user interface for you to do this. But yeah, it's sort of thinking about what kind of methods, how we're going to implement things. So maybe what I'll do is I'll leave that up. So if you are on Mentimeter, you can whack in the code at the top. So that's 38975104. And, so you don't feel pressure with me looking at, the screen and waiting for your responses to roll in. You can just put them in whenever you want. I wonder whether we can access social media library for free. Yeah, it's such a difficult one at the minute because I've noticed that so I know that Reddit has I don't know whether they've scrapped their API. There's definitely now it's definitely now hard to access their data. There is talk of a new research API coming out, but I do know that you can still access, like, people store the data, from like previous APIs are available. So there will be some Reddit data sets out there. You can access these sort of data dumps. I just don't know how, I don't know the sort of like ethics of that as well. It's a kind of murky sort of one. And then we've got X. So those of you that use X will know that, Elon Musk has now made sure that the API unfortunately isn't accessible for free anymore. So again, that really cracks down on people being able to scrape Twitter. I know there is potential ways around it, but again, ethically murky, and they are really cracking down on bots that do try and scrape data. So yeah, it's going to really depend on what social media sort of platform you're looking at. It's a shame because there is so much data available on things like X and Reddit, particularly related to like sort of political topics. But yeah, I mean, you'd have to check out if there's other APIs for so APIs are what we use to retrieve the data from these sort of social media platforms. You have to look at whether these APIs are accessible for other sort of social media platforms. I know TikTok, I think that's, you can scrape some stuff from there, but that's all video format, isn't it? So you'll probably be scraping like hashtags as opposed to like more sort of longer form content like Twitter and stuff. Sorry, let me just check through. So someone's just put in the chat, is there an opportunity for a volunteer shadowing on any of the projects you and your team are working on? Thank you. I would just say get in touch, just send me an email. There's an email at the end of the, what do you call it, slideshow thing. Send us an email and we can definitely look into that. I can't make any promises because I'm not the boss of my of my department, but yeah. For research reasons, researchers can apply for Facebook data access. See the link. So I'm sorry if I butcher your name, but Legion has put a link to that in the chat. So if anyone is interested in Facebook what do you call it, data, then do check out that link. Okay, so let's sort of move on. So for step 5, we will experiment and analyze the data. So you will be running the experiments, building the models, and analyzing the data, or otherwise just using the methods that you selected in the previous step. So, and then you're going to want to identify and explain the results within the context of the sort of model or the method that you've used. Then, once you've run your experiments and you've analyzed the data, you can start to interrogate the results and form some conclusions. So this means sort of going beyond the experiment, the model, or the method to draw some conclusions about what the results mean. So what sort of picture they're forming. For instance, do they support the policy recommendations? Do you support policy recommendations that have come out from your research? Who or what do these results affect? Why does it matter? What should change? Who benefits from the proposed change? So, we had that example, didn't we, of looking at how people move through cities. Perhaps that I found that people with disabilities related to mobility have more difficulty navigating through particular areas of the city centre. Maybe there are uneven surfaces or particular roads that are too narrow, in which case you can then recommend some changes, which might be as simple as, okay, XYZ place needs wider footpaths. And then as we're nearing the end of the research process now, we're going to focus on communicating and sharing our research. So in terms of communicating your research, it's important to understand that all of the previous steps must be communicated to multiple audiences in multiple different ways. And what's really important is that you think about short-term and long-term engagement. So for a lot of us, there might be some that are watching that are in the social sciences already, or in the academic world, I mean to say. So you might mind might go to, well, I want to get this published in an academic journal, which for sure, is definitely important, but it is also good to think about other forms of communication. So are you going to present your work at a particular conference? Or maybe you could submit a piece about it for a blog. So I know, for instance, like there's loads of like sort of blogging websites now that are really popular and they're free. So Medium, Substack's a really good one for like sort of like computational social science kind of stuff. You can just type up a post and then you can share your link to it. You know, or maybe you want to think about whether there are any workshops or classes that you could present on to get your research shared more widely. And with that, you want to think about how you are going to adapt your style and tone of communication to suit those different audiences. So, presenting at a conference is very different to writing an academic article. You might want to, make it a bit more, I don't know, like sort of accessible and maybe even a little bit more fun at a conference. So you're going to think about how you need to adapt your style and tone of communication. Or if you're writing a blog post, for instance, maybe you're going to want to make things super, super introductory so that you can get your work out there to a wider sort of readership. And yeah, finally, you're going to want to share, document, and validate your findings. And when we talk about sort of validating your research, um, it's about making sure that the right thing was done by allowing your work to be studied, reproduced, and or modified as needed. Sorry, one sec. Hmm. So to do that, you want to allow as many people as possible to be able to access your methodology and any code or data. You want your research to be as transparent, well documented, and open as possible. And of course, there's going to be caveats to this. So you might be working with, for instance, administrative data that's super restricted. So you could consider workarounds. So one thing you could do is create sort of like a dummy data set so that people can still run your code and work through your methodology, but you're not releasing anything that's disclosive. And this step is really important because reproducibility is a really important part of research, and unfortunately, it's often neglected, which is why it's good to think about how you'll document your work before your research gets underway. So yeah, I know myself, after having sort of left this step to maybe towards the end of my project, I've really lost those important insights. Like, well, why did I use this Python package when there's this other package that seems to be the one that everyone's using? Well, I don't know now because I didn't sort of document my process as I was sort of going through things. And it might be an insight that really helps someone else out who's going to be doing the particular sort of analysis that I'm doing later down the road. So yeah, documentation often considered quite a boring and annoying step, but definitely an important one. And just a few things to note at the end. So we are sort of coming to the end of the workshop now. So one thing I want to stress is that these steps aren't linear. So there are many points from each step that you'll need to return to or apply throughout the research project. So for instance, documenting your research, like I've said, is something that you will want to apply from the beginning. And when it comes to computational social science projects, most or all are going to require many iterations. That means revisiting certain steps. So for instance, you might come up with a research question in step one, but after exploring the problem further in step two, you might want to jump back and then reformulate the research question in light of something that you've read. So you might want to really tone it down, make it more specific, if that makes sense. Or maybe you're on step four and you've implemented your method, but you actually need to go back to step three because you've not outlined the concepts and the processes enough. So again, that's really why documentation is so important, so that you can capture all these nuances and changes as your research evolves. And it's really nice to sort of see when people do this, because then you realize that, it's not a straightforward process. I'm not alone in having to make these changes. I'm not alone in having to adapt things, and they came across this problem. Yeah, that's something that I've come across as well. So it's really important, and it's also quite nice for other people to follow through your steps. And it's just a good habit to get used to. So when you're sketching out your research question, just note down why you think it's important. And what you'll find is that the research then kind of writes itself, and it's a much better process when it comes to writing it up. And when it comes to your code as well, so a good practice is often putting it in a code repository to protect it. And you can also put it in the cloud and make it available for others to look at, which is great because then, often when you've spent so long looking at your own code, it then becomes difficult to spot issues with it. But if you have a colleague look at it, it can be helpful because they might spot a problem that you've overlooked. I've had it for ages where I've been like, this piece of code just won't work. I've tried everything, and then it's the case that I've misspelt a function, and it's crazy, but it happens. Or in R, R is really finicky about brackets, and someone will look at my code and they'll be like, "There's a bracket here, it shouldn't be," And yeah, and it's like we talked about at the beginning, it's really important to be open-minded and remember that you don't have to know everything about computer science. You just have to know enough to be able to have those productive collaborative conversations with those in the field. I definitely didn't consider myself, and maybe even still don't consider myself like a particularly like STEM person. I don't really think, I definitely didn't feel like it came naturally to me to sort of get into this, but I think when you have like sort of like that social science background, it can become a bit easier over time to then pick up these concepts. So like, don't worry if you find things a little bit difficult at the start. It's natural. You're learning something new, and it's natural to be a little bit intimidated by programming because it just seems like you see like on CSI or something, they'll be coding and there's like loads of green text, and it seems like you have to have this big mega galaxy sized brain to do it. But um, there's loads of really good tutorials out there and stuff, and you have those skills as well. Like I said, if you come from a social science field, don't discount the fact that you do have a lot of those skills already and a great foundation to build upon. So we do only have a few minutes left. I'm going to skip on from this. You can put some stuff in there if you want. It's just another word cloud. So you can share your last minute takeaways on what CSS is and maybe why it's important. But these are also the references for anyone that is interested. And we will be making the presentation slides available, so you can always go back and look at these in more detail. But I am going to go to the Q&A, and you can see as well that I've got my contact details on here. I am sort of on Twitter now and then, not really a lot on my work account, but I am going to try to start sort of posting there a bit more. But you can follow our UK Data Service account on, it should say X, but on X as well, if you want to see what other events we have going on. Thanks so much everyone for coming, and I hope it was useful.